All right, number 27 here. So I have to go ahead and find the value of x. So, well, what I can do here is realize that these two angles are remote interior angles, and they're going to add up to equal 115. So you can go ahead and set up an equation just like that, where 115 equals x plus 55. Subtract 55 from both sides, you get x equals 60, and there's your answer. Another way to think about it, these two add up to 180 because this is a linear pair. So 180 minus 115 equals 65 degrees. And then these three angles have to add up to 180. So I could just do 180 minus 65 minus 55 equals x. And so when you do that math, you get 60 degrees, which is the same answer that we had before. Number 28. So here, again, all three angles in a triangle add up to 180. So we're going to set up this equation where I took all those angles, add them up to 180, combine my like terms, solve for x, and I get 29.8. And then it says find the measure of the interior angles to the nearest tenths. So I know x, I got to plug that back in to each one of these expressions here to find out what each angle is, and then those will match answer A. Okay, so here we have find the missing side lengths and angle. Oh, shifting the camera here. So first off, these two triangles are the same, so therefore, you know, W is going to be 31 degrees. It's going to match up and correspond with that. Z is going to be 10.5. You know, V here is going to be 5.5. X is a right angle. Y is 59 degrees. So when you put all that together, you go ahead and get C as your answer. Now, number 30, it says in triangle ABC, if triangle ABC is congruent to DEF, the AB is 2 feet, which means DE has to be 2 feet because that's also the first two letters. Angle B is 33 degrees, which means angle E is 33 degrees by looking at the congruent statement here. And then angle F equals 39 degrees, which is the same as angle C here. So when you go ahead and do that, first off, you can go ahead and draw a picture as I have. Is the camera going to come on? I'm just going to shift it by hand. So here I have a picture that I drew from the given information. Remember, all the angles in triangle add up to 180, so we were able to find the third side. And so what you can go ahead and conclude is that angle D has to be 108, which is also going to match angle A in the two triangles. So number 31. All right, refer to the figure below which of the following statements is true. So here's two triangles, and if you want to think of this, hang on one second while I adjust the camera. Oops. All right, so you can actually break these apart if that makes it easier for you. So you're really looking at two triangles, which look kind of like this, and they're the same. So you have this pair of sides is congruent. They tell you that these sides here are congruent, and then you have this third pair of sides that are congruent. So then it's got to be congruent by side, side, side. Based on the picture and what they give you, you could use the reflexive property to say HK is congruent to itself. It's not side angle side because we don't know anything about angles. This statement's not correct because you can see the ordering of the letters. So like angle H matches angle J. Here, which is false. Angle H does not match angle J because angle J is up here. It's a small little angle. Angle H is this big obtuse angle here. So, and it's got to be this value right here. So that's it. Number 32. What must be true in order for a triangle ABC to be congruent to EDC by side angle side? Okay, so what we're looking here is we would need to know that AC is congruent to CE. We already know that BC is congruent to CD, so that's a side. We know this angle here, these are vertical angles, we know those are the same. So to be SAS, we'd have to have the angle that's congruent in between my two sides. So it's not going to be AB is congruent to DE. That's not right. It's not going to be one of the angles because we've already got our pair of angles are congruent right here, which is BCA is congruent to DCE. And then what we would need to know is that AC is congruent to CE. So number 33. Here I know that, again, these are my vertical angles, so these two are the same. They tell us these angle A and angle H and angle L are the same, and HJ is the same as JL. So we know all that. This is angle, side, angle, side, angle, so that I know these two triangles are the same even. And again, it's not SAS, and it's not, so it eliminates those two. And then again, here you're saying angle H is the same as angle K, which is not true. Angle H corresponds with angle L over here, so that's why it has to be this statement for A. 34. Angle B is congruent to angle E, angle C is congruent to angle F. What other piece of information does he need to show ABC? So we already know that B is congruent to E here. I know that C is congruent to F here. I need to know that angle A is congruent to angle D. I'm sorry, I don't need to know that. I just need to know that the side in between these two angles are congruent. So that's going to be BC is congruent to EF. And if you want to draw out a picture, this is what you would have, and you can see clear that BC has to be congruent to EF in order for it to be by angle side angle. All right, 35. So is QR congruent to SR? All right, that's our question. The answer is yes, and it's CPCTC. It's going to be an isosceles triangle. So first we'd have to know these two triangles are congruent. And I know that's true because this is reflexive property, so that's congruent to itself. These are both right angles, so those are the same. And then QT is congruent to TS. That's also there. So now I have a side angle side situation. So those two triangles are the same by SAS, which means that QR here is congruent to SR by corresponding parts of corresponding triangles. I'm sorry. Yeah, corresponding parts of congruent triangles is congruent. That's what CPCT stands for, only used after showing two triangles are congruent. 36. What is the measure of each base angle of an isosceles triangle? So if it's an isosceles triangle, automatically I know this angle is congruent to this angle. So I don't know what they are, so I'll call it X, but I know they both have to be X. So then I can come up with this equation. It adds up to 180 by adding them all three up. Solve for X, I get X equals 70. Plugging it back in, it's still just 70 degrees. 37. Find the value of X and Y. So again, this angle here, you can go ahead and just do 180 minus to get that angle. Or you can notice it's an isosceles triangle. So we don't know these, but these both have to be the same. So these are both 64 degrees, and then this is X, so you can come up with this equation. Solving for X, you get X equals 52. Once I know that X is 52, then I can go ahead and plug that in and find out what each angle is. Just to be clear, 180 minus 116 equals 64. And that's where these values come from by doing 180 minus 116. Get that right there. Number 38, triangle ABC is congruent to triangle DEF, with AB being congruent to BC. Okay, so that means also DE is congruent to EF. Which statement of congruence is not provable? Well, if DE is the same as EF, then I can switch these around. So A could be true. And if you want to just draw two pictures, that might make it easier here. I have triangle ABC. I'm going to draw this triangle the same as this, DEF. Given they're the same, and I know AB is congruent to AC, so it's an isosceles triangle. Okay. So the problem, all the A, B, and C will work. The problem with D is you're saying ABC here is congruent to FDE.